Hey guys, today I'll be doing lead code 230, kth smallest element. This is a medium question on lead code. Now before I start solving the solution, I'll just give a hint. Actually lead code did give this hint, but think of the possible traversals. So I've shown that there's three types of traversals, post, tree, and in. Think of traversals and try to do a traversal on these two trees that I've given. I've taken them from the question example, but think of traversals on these trees. Now once you've done that, you can keep listening. So what is the traversal that we want to do, right? First of all, there's some people might think that we can have a local variable, and then we can basically try to find the smallest integer, and then we can increment the count this variable, and then once this variable hits k, that will be our answer. But that's not possible because you would have to always keep in track the, like, it wouldn't be possible this way because you would have to keep track of the, so let's say if you went to 3, then you went to 1, then you went to 2, but if you had a node on your right tree that was smaller, you would end up messing up the order, so it would just be more complicated than it should be, right? The easier way to do it is to literally just process the nodes. So if we say results is an empty array, and we will process the nodes, and the way we process it is by using in order traversal. Now why in order? Let me show you. So if we consider 3, 1, 4, 2 as the tree, alright, in order, by the way, LNR, so left node and right. The first thing we'll do, we'll go to 3, we'll ask 1, do you have a left? 1 doesn't have a left, so we'll go right. We'll first take out 1 over here, so in our result, so let's consider a result array 1, remove it from here. Okay, so we did 1, now we go to 2, we'll add 2, then we'll go back all the way to 3 now because we've done 1 and 2. We'll go to 3, we'll process 3 immediately, and then we'll go to the right, so 1, 2, 3, 4. Now that array is already sorted, if you can see, and just to make it more clear, I'll show it on the other one as well. If we do go all the way to the left, so we'll go to 1 first, then we'll go back to node 2, we'll go back to node 3, we'll go to the right 4, then we'll go back to the node, and then 6. Again, it's sorted, and we just want the kth being, so if they give 1, right, so for the first example, if you're given this list and they want k equals to 1, they basically want the first element of the list, so we would say k minus 1 at index k minus 1 of the array, and that's literally it. So just to write it out in code now, pretty simple. If you've done your traversals, it's literally the same, except this time you just add it to a list instead of printing it or storing it somewhere. I have a helper here. Always like to have one. If not root, we just return, that's our base case. Helper, call it on the left, right? Left node right, so call it on the left. Then results, the value that we are at right now, then do the right, and that's it. You can just leave the function alone, call the helper outside, and at the end just return result k minus 1. So that's the index that we want. right? And it will give you the which index you basically want. So if I showed it on the second example as well, k equals to 3, 0, 1, 2, 3, 4, 5, we would say 2, so the third element in the list, and we would get 3 as our answer, which is the answer. All right, that's it. Just remember your traversals, and whenever you do it on a binary search tree, so in particular binary search tree, in order will always give you a sorted array.